So the next thing we're going to cover then is we're going to finish up this section 8.2, call this 8.2b. We're going to talk about different rules for our exponents with rational exponents today. So several rules to talk about in this lesson, really the second part of 8.2. So let's go ahead and kind of get going with these rules, and I'll put a little bit of a pause in the video. This is something that you do need to get into your notes. So I put a little bit of a pause into the video and kind of stretch this one out just a little bit so that you can get these written down, or I'll just ramble on here for a couple seconds so you can get these written down and talk about them quite slow. So rules for rational exponents. So when we're talking about rational exponents, we're talking about a base to a power. And we've talked about that before, but so when we're talking about the different rules, so let's say that R and S are rational numbers. For all real numbers, A and B, for which the indicated expression exists. So the first one is that if we take A of R times A of S, meaning that they have the same base, but they're two different exponents. What we do with those exponents, we can combine it from a 2, as long as they have the same base, A, in this case, you can combine it down to 1 by adding your exponents. So if you multiply bases that are the same, add their exponents together. Okay? That's kind of the first one. The second rule that they look at in here is they look at what happens if you have a negative exponent. So you have a to the negative r. If you have a to the negative r, that's the same thing as 1 over a to the r. So you just move it from the numerator to the denominator. Okay? Simple and easy enough. When you divide, when you take a to the r divided by, that should say a to the s, not b to the s. That should be an a. They have to have the same base. So a to the r divided by a to the s, you subtract exponent. So that's equal to a to the r minus s. You'll oftentimes hear me say, where's the exponent bigger, on the top or the bottom? And if it's bigger on the top, then you're going to do your subtraction in the numerator. If it's bigger on the bottom, then you'll do your subtraction in the denominator. Okay, so that's the division rule. The next one is the power rule. It says that if you take the base a to the r power, then you take that to the s power. That's the same thing as a to the rs. So you multiply the exponents when you go to a power. So a to the r to the s is equal to a to the rs, r times s. When you take multiple bases to a power, it's important that you take each of those bases to a power, and that's what the next one says. It says a to the b, a times b to the r power. That's equivalent to a to the r power and b to the r power. And this one gets missed a lot. So if you have something like 2x to the third power, you have to take the 2 to the third power and the x to the third power. And we'll look at some examples here in a minute. The next one, a divided by b to the r, just like if they're multiplied, they're divided, you have to take this power to each of them. So that's a to the r over b to the r. If you take a divided by b to the negative r, that's just like flipping it. Because if you think about it, you would have a to the negative r over b to the negative r, but we don't like negative exponents, so you just switch them around from the numerator to the denominator to make it b to the r over a to the r. And then the last one is just another way to write it. A to the negative r is also equal to 1 over a to the r. It's a different way to write it, but they all mean the same thing. So those are the rules that we have and that you need to know and understand for the different rational exponents. So let's go ahead and then look at some examples. We're going to write with only positive exponents and assume that all variables represent positive reals. So we've got 3 to the 1/2 times 3 to the third. So they have the same base of 3. So since they have the same base of 3, we're going to take the two exponents and we're going to add them together. So on the side here, we have to go 1/2 plus 1/3. And you add 1/2 plus 1/3, break out the calculator. If you have to, you shouldn't have to, but we're adding. So it's 1/2, 1 ABC2 plus 1 ABC3, and it gives you 5/6. So then this is going to equal a to the 3 to the 5/6. They have to have a common denominator, and they showed you the common denominator was 6. That's how they did it. But grab the calculator. Use the calculator. The important part is you understand that you have to add the exponents if the base is the same with those. The next one, you're subtracting, or you're dividing the same base. So if you're dividing with the same base, you have to subtract. Again, I kind of always ask which one's bigger, which exponent is bigger, the numerator or the denominator. Then you don't have to worry about moving it around like they'll probably do when they do this. But 4/3 is bigger than 2/3. So I'm going to go 4/3 minus 2/3. And when you do that, you get 2/3. And since that was in the denominator, this is going to be 1/7 to the 2/3. And that's fine, just leaving it just like that. Now, my guess is they'll subtract them. They get negative set, and they just do they do 2/3 minus 4/3, which is negative 2/3, and then they just move it to the denominator. It's the same thing we did. Okay, which one's bigger? Okay. The next one, now we've got a whole bunch going on. We've got division, we've got powers, we've got a whole bunch of different things going on in this example, so you have to remember what the different rules are. What I like to do first anytime I'm doing this type of problem is I like to simplify what's inside parentheses first. So I've got a base of A and a base of B in the numerator and a base of B in the denominator. So since I have B in the numerator and the denominator, I can go ahead like we just did in the last example and subtract them. Okay, so now I have to understand that there's a 1 understood to be there. So 1 is bigger than 2/3. So 1 is the same thing as 3/3. So 3/3 minus 2/3 is 1/3. So I could actually write this as A to the 1/3 over B to the 1/3. And now this all has to be taken to the 6th power. So now we're going power to power. When you go power to power, you multiply the exponent. So we have to take 1/3 times 6. So 1/3 times 6 is the same thing as 6/3, which is 2. So this would be A squared over B squared. And that's your solution. Okay, I like to work from the inside out when I'm doing this type of problem. Okay, that helps me. Let's see how they did this problem. I'm interested to see how they did this problem. So I'm going to get all my stuff kind of out of the way here and see exactly what they did. Okay, they just simplified it a little bit the same way I did. Really, they've got A to the 1/3 and B to the negative 1/3. We just put it in the denominator. Okay. That gives them 2 and negative 2, and then you just drop it down. Same answer we had. Good way to do it. Okay. Next one. So we've got A to the 3rd, B to the negative 4th over A to the negative 2, B to the 1/5. So a lot going on with this one, and then all that risen to the negative 1/2 power. Okay, so I'm going to work on the inside first. So I look at the base of A. It's got an exponent of 3 and negative 2. So what's bigger, 3 or 2? 3 is bigger. So my A is going to go on the top in the numerator. 3 minus negative 2 is 5. So I've got A to the 5th on the top. Now I look at the B. You've got negative 4 and then 1/5. 1/5 is a bigger number than negative 4, so my B value is going to go on the bottom. And that's going to be 1/5 minus negative 4. So I break out a calculator. 1/5 minus 4. And I get negative 4 and 4/5, which is negative 20, which is 24/5. I'll just do it over here. So 1/5 minus negative 20, or so 21. Sorry, it should be 21/5. It should be 21/5. Okay. So 21/5. Then we have to take all that to the negative 1/2. When you take something to the negative 1/2 power, you multiply, and we're just going to multiply it. So if I go 5 times negative 1/2, 5 times negative 1/2, just kind of do it up here. 5 times negative 1/2, that's negative 5/2. So I've got a to the negative 5/2. Cross this out if we can. Erased. So we've got a to the negative 5/2 over b to the negative 21/5. Now we can't have it like that, so we got to flip it over. So you're going to end up with b to the 21/5 over a to the 5/2 for your solution. Okay. And let's kind of clear all of this out of here and see how they did it. Got a bit of a mess in there. A lot of stuff in there. Looks like how we did it. Looks like what we had. The 21/10. Okay? And there's a solution. Next one. So we've got r to the 2/5 times r to the 3/5 plus r to the 8/5. So we got to distribute. So we're probably going to take care of this part of it first, inside parentheses. So what do you do when you add? Can we add them? I don't think so. They have the same exponent. Let's distribute. Do we have a rule for adding? I don't think we have a rule for adding. Okay, so we're going to distribute this. So if I go r to the 2/5 times r to the 3/5, what do we do when we multiply? We add. So 2/5 plus 3/5 is 1, so that gives me r plus, now we have to take r and add that, so that gives me 10/5. So that's r plus r squared, and you can't combine those. They don't have the same exponent. So you can't combine those, and that's why we couldn't combine them right there, is because they didn't have the same exponent. So that's why we have to use the distributive property for that question, because we don't have a rule for adding. So there's the same solution that we got. Okay. Next one, it says all radicals as exponentials, and then apply the rules. So in this case, we've got them as radicals, but we want to apply the rules that we just used. So we have to take these and do what we did in the last lesson and rewrite them. So we're going to rewrite the 4th root of x cubed times the 5th root of x. So remember, when we write these, I can rewrite the 4th root of x cubed as x to the 3/4. The index goes in the denominator and the power goes in the numerator, times x to the 1/5. And it's rewriting just like we did in the last lesson. Now we can apply the rule. You add. When you multiply, the same base, you add. So we go 3/4 plus 1/5. That's 19/20. So our solution here is x to the 19/20, which if we wanted to put it back into how they did it, would be the 20th root of x to the 19th. Those things are the same thing. Okay, that's exactly what we got. So we've got, next one, the square root of x to the 5th divided by the cubed root of x. So we're going to rewrite them. This is x to the 5/2. Remember, there's understood to be a 2 there if there's nothing there. And this is x to the 1/3. So which is bigger, 5/2 or 1/3? 5/2 is. So we're going to subtract now 5/2. So 5abc2 minus 1abc3. And it says it's 2 1/6. Well, how do I do that on my calculator? on your calculator, if you get 2 1/6 and then you hit that second ABC button and hit equals, it'll change it to an improper fraction for you. So this is x to the 13/6. Use the calculator to help you through these. Again, understand the concept, subtract fractions, whatever. Okay? Same answer we got. The next one, the cubed root of the 6th root of x. So let's start on the inside. Let's rewrite the inside. So that's going to be x to the 1/6. And then, this is interesting. This is going to be x. Well, the 3 goes in the denominator, and the 1/6 goes in the numerator. So essentially, we've got x to the 1/6 divided by 3. 1/6 divided by 3. I'm going to do that on my calculator. 1/6 divided by 3. It says 1/18. Okay. So that's x to the 18th. And there's your solution. And complicated as heck. X to the 1/18th. That's what it says, 1/18th. I'm sorry, my calculator said 1/18th. See? It's backwards. But it said 1/18th, I just said it wrong. So 1/18th. So there's our solution. Complicated, but just rewriting them. So there are our rules that you have to have for today for the second part of 8.2b, and understanding these rules. So you've got your assignment for the day. It's inside of the Pearson, so best of luck with that. Stay healthy, and we'll see you in the next video, which I'm going to make here in about 45 seconds.